We actually learned a little bit about data cleaning last time, but we didn't talk too much about the examples. So today I will show more examples how to do like remove duplicates and replace NAs. And then we will learn about data wrangling, which means like we can change the format of the data frame to make sure it can be used by some like especially by some plotting functions we will learn next week. Previously, we learned that we have some functions to determine if there is NA in the data frame. And also we can remove the NA rows and also replace the NA values with a specific value. So assuming, for example, we have a series and there are some NAs there, and we can just use drop NA to directly remove those two elements. And if it's a data frame, this is the original data frame. There are some NAs there. If we use drop NA, it will just defaultly drop all the rows that contain NA values, no matter like how many NA is there. But of course we can also any questions? We can also let the function to drop NA based on the columns. So here, because sometimes if there's only one NA, we remove the entire row or column. It doesn't make sense, right? We can tell them ask the function to drop row or column if all of the element is NA. Since this how equals to all means like drop all the columns with NA values. So if we perform this statement, you can see nothing is removed. That's because we base on each column, every column has some values and has some NAs, so nothing will be replaced. And actually, a more commonly used strategy, instead of remove that row, we just exchange the NAs with a specific value. So for example, very commonly used way is just to replace it with zero, especially when the data is very large. Like we have tens of thousands of features. It doesn't matter you change a specific location to zero. It's fine. So just replace that specific location. For example, here, I just use fill NA to replace all the NA with zero. You can see now it's zero. And also, if for certain columns, I want to use different values to replace NA, I can use a dictionary here to ask the function to replace the NA to a specific value for specific column. So this means like the first column, NA is replaced with 0.5. Second column, everything, NA is replaced by zero. Yeah. There is also two functions. One is a forward fill, the other one is a backward fill. Actually, this might be used for certain tasks, but I don't use it regularly because this is, for this function, it actually fills these NAs based on this like original previous value. For example, this one is the NA its previous value is still NA, right? So actually, after I use this function, nothing changed. If I use B fill, it's backward fill, like all the NA is filled by this minus 1.567. Yeah, so this is similarly this one, everything is filled by the next value after the NA. So it could be used for sometimes, but most times we just replace the NA with zero, or we can actually replace the data using the mean value. Like if that's missing, we can just using the mean value in that column to represent it. So for example, this one, every NA is just replaced by the mean value. Yeah. The fill NA function take all these kind of arguments and like the along which axis and also how to fill the values. And also in place, we just directly work on the original data frame. So just use them whenever you need it. Another way, method commonly used for pre-processing is remove duplicates. For example, this is a data frame, and it has the this is like the sixth row and the seventh row. These two rows are actually the same. And if we use duplicate this function, it will tell us that this new row is a duplicate row. And if we just use drop duplicates, that specific row will be removed, and now we have non-duplicate data frames. Another commonly used strategy for pre-processing is map. Like sometimes we actually in the final project, we have a question like based on the existing data frame, create a new data frame. That's kind of way usually we need to do to the original data frame for pre-processing. For example, this question here, there's a data frame. It has two columns. One is food. It's like what kind of food it is. Like, is this ham or bacon or whatever? And the second column is ounce, like the ounce of that item. And if we want to convert this food name to its like animal, like because we know bacon is from pig, right? And corned beef is from cow. So we can just use a dictionary and give it to the using the map function to ask it to convert everything from one column to another column. So you can see this is the original data frame, and the new data frame, we create a new column called animal, and all the values in this new data frame is generated based on this map function. It will just search the food column and use the map using the dictionary to convert every element to the new element. So this is a commonly used way for us to do kind of pre-processing, just to convert the existing data to more meaningful data we can use in the future. Also here, there's this function lower, it will change all the character to lower cases. Sometimes it's very like convenient because you can see there's a bacon, capital bacon, and a lowercase bacon. They are the same. It's actually very common in human-made files. People will use different terminologies for the same thing. So we need to convert these IDs to make sure the information is properly gathered. So another thing about pre-processing is instead of NA, sometimes the data just has some outliers. Like this one, it's a series, right? But this minus 999, it's totally different from all the other numbers in this data frame. So we can actually replace them by NA. So after that, actually, of course, this one is also an outlier, but we can actually replace based on like this one just specific replace this value to null, but we can also of course using like maybe value larger smaller than minus 999 and this kind of way to first remove those outlier to NA, and after that we can then try to maybe using the mean value or maybe using 0 to replace these NAs. This kind of I mean, of course, we can directly change those outlier to 0. That's totally fine. But sometimes we don't know, we are not sure like how to deal with them. Maybe it's okay. I mean, it's better to first use NA to represent them. And as long as these NAs are in that data frame, when we apply some function, it will report an error. And I mean, in the future, let's say I forgot to replace them with 0. I run the function, oh, I got an error. I know, okay, I haven't finished the pre-processing. I need to be careful and redo that steps. So this is why, I mean, although NA brings a lot of trouble, but they are still used in this data analysis. So yeah, this is another example. We have a random generator matrix, 1,000 row, 4 columns, and we can use a describe first to get all the statistics from this data set, like the maximum value and the number, how many numbers are in each column, sort of things. And if we want to remove those outliers, we can actually use like we can first compute the absolute value in each column. And if that value is larger than 3, we assume it's too large or too small. We can just replace it with 3. If it's a positive, this np.sign, you get the sign of that number, right? So if this is a positive number, it will turn to 3. If it's a negative number, it will turn to -3. So after this conversion, now we have like still the same quantum number, but minimum number is -3 and the maximum number is 3. Yeah, that's also how we can solve the outliers from a data frame. Yeah, that's all about the data pre-processing. Basically, just remove NA, remove outliers, and remove duplicates, and that's all. Any questions? Okay, then let's move to the next module called data wrangling. Actually, this wrangling, this word, it's not a very commonly used word. In most cases, we just say reshape the data or combine the data. Yeah, we will actually further discuss this later next week. Let's take a look. So this is a typical data set, human-like, right? Each row is a sample, each column represents some features of the data, like the year or CPI or whatever values we obtained. It's very easy for us to read, but sometimes this is difficult for the like the plotting function to read them. The functions may need another different type of we will check about later why we need to do the reshape kind of functions, manipulations. So before we talk about that, we first see how we can merge several data frames together. So here is two data frames, two series. This is two series. It has two columns, one key and one data. And if we merge them together using the merge function, because we didn't tell the function which specific column to use to merge, so they will basically just merge based on the common key, which is common column names, which is a key, and only the keys that are common. The keys that are intersection of these two columns are within the new results. So you can see only BAB is included in the new merged data frame, and the value is the data one, data two column value is added into this new data frame, and based on its original value. And if the column names are different, for example, these two data frames very similar, but now it's LK and RK. It's different, right? But we can still merge them together. We can let them ask the merge function to based on these two columns, and then again, this function will just search the similar column values and use them to merge them together. So you can see the new data frame, similar results, but this time there's a 2K, LK and RK here, and the value is merged together. So these we didn't specifically say how to merge them. So this kind of merge we call it inner merge. Inner join is basically just only the values that exist in two data frames are used in the new data frame. If we use this outer join, which means like the union of those keys to merge two data frame, now everything is merged in this new data frame. If there is a value in that original data frame, there's a value. Otherwise, just NA will replace that location. Yeah. There are very many different ways. There's 4 different ways, like inner, outer, and also left, right. Basically, just like a left is just use the keys on the left table, and right is use all the keys in the right table, determining on how you want to join different data frames. Yeah. So that's for like a series. If we want to do it for like a data frame, we know that in NumPy, if we want to concatenate, merge two data NumPy arrays, we can use this NumPy.concat to concat the two made arrays, right? The original array is a 3-row, 4-column array from 0 to 11, and then these two arrays will be concatenated together based on the axis. Axis equals to 1 means they are along the columns and everything is concatenated together. But what if I want to do it for pandas? In pandas, if we still use this concat, default, it will just merge based on the axis. And this time, you can see everything just aligned together and similar to the NumPy one, except this time there's an index here. And also, if we just tell them to do it along the columns, similarly, everything is concatenated together. But this time, unlike the NumPy, because we have index, right? If the corresponding index doesn't have a specific value, NA will be replaced in the generated data frame. Similarly, if we concat two data frame, generate a new one, and concat it with the existing one, we will get the merged data frame. But if we specify, I want the concat function to do at like using the inner join. This way, only the index that exists in both two data frames will be included in the final result. So, of course, I mean, that's the when we want to care about the index. If we doesn't care about it, we just want to treat this two like data frames concatenate together, we can just ignore index and they will be concatenated based on just like simply like a NumPy concatenation. So yeah, that's about merge several data frames. And then let's have a look at this different data format. I mean reshapes. Before that's we talking about reshape, we need to learn this idea called hierarchical indexing. It's like based on, I mean, using this function, we can actually have multiple index level on the same axis. Like for example, here for the index, I have two lists here represent like so it's 1, 2, 3, 1, 2. These are the index for this series, right? And also we have A, B, C, D, another layer of index. So using this kind of technology, we can actually like A, B, C, they are different groups of data. Like when we analyze them, we can actually directly using the index in the first part to like do some kind of subset from this original data set. I mean data frame. This way, like it's useful for like kind of we can do some more complicated task. And of course, actually, why we talk about this is this kind of data frame is called a long format data frame. So you can see it's like a very long list. Like each row, there's only one value, and but different things to denote it. If we and this kind of way, if we use unstack function, we can actually change this original data frame to a like 4 row, 3 column data frame. It's the same thing like in the original one, like A group has 3 values, right? D groups have 2 values. If there's no value, NA will be filled that. This kind of data frame, we call it a wide format data frame. This is similar to the text file we just saw. It's like a human-friendly way. Like each row represents something, each column represents something. And this long format is more commonly used for functions, like because some functions they just read one value at a time, and they can better use them to plot something. So of course, I mean this unstack is a function that to convert them from one type to another, and of course we can do unstack and we can also do stack, which will then convert back from wide format to long format. So let's see another example. So this is a new data frame. It has this is wide format, 2 rows, 3 column. And if we use stack, it will become like a data frame with different hierarchical index, right? And unstacked again will convert it to wide format. So stack and unstack are two functions to do this kind of conversion. And there are another two function that's actually more popular, more commonly used to do this kind of conversion. One is called pivot. The other one is called pivot. The other one is called melt. So let's read this file, this macro data we just saw. You can see there are so many rows and columns. And if I want to generate a new column based on the year and quarter information, I mean, I can convert these two information together and generate a new column. In this new column, instead of using this quarter, I want to use using the days to represent the specific day of this thing, and using end day to represent, for example, quarter one, I just use March 31st, the last day of the first quarter as that day. And of course, quarter two is like June 30th. Yeah. We can then create a new column based on the information in year and quarter. And also, because this data frame is too huge, I just, to make it simple, I just use the data in these three columns to show how we can convert them from one format to another. The first example is using a stack. We can see we use stack and convert this data frame into a long format data frame. In a new data frame, this date is a newly generated one, right? This is based on the quarter and the year, we can get a specific date from this for this data set. And also these are three columns. At the beginning, it's just three columns one by one. But now when it's converted to a long format, because every row there's only one value. So it's like each row now becomes three rows. Like this column, this value, this column, this value, this column. Like every row in the original wide format now it's become the three rows. Of course, because we only use these three rows, right? If we use the entire data set, these are 12 or 13 rows. Of course, each row will then become 13 rows. Yeah, this of course this is too huge. Originally, I think it's only 200. Now it's 600. It's not okay for us to analyze. But for the functions, for Python, the programs, it doesn't care how long it is. So this kind of format is more commonly used for plotting functions. So we have this long format, and then we can actually use this function pivot to convert it to wide format. You can see now it's one column now changed to three columns. The period function format is I use the date as the index and use the column atom as the new columns, and the value is a value to fill out this matrix, this data frame. And this way we can convert it. And this is similar to unstack. So this, let's see a simple example. If it's a data frame and this is a new data frame in wide format as 4 columns, and we just melt it. Change it to long format using the keys. So in the new long format data frame, and everything will just convert it based on the key of the column. And also if we use pivot, and similarly, it can be converted back to a wide format. The thing is, this one is a little bit different from the original data frame. That's because pivot results into a hierarchical index. So if we just want to return it back, we can use this reset index. This way, we can just resolve that hierarchical index problem. Let's see an example. So we have a data frame and a few columns, and it's about some fruits and their price quantity. There are 4 operations. First is we can change all the value names, product names to lower cases. And second one, remove those outliers. Third one, remove any duplicates. And finally, could calculate the average price for product. So I will give 10 minutes for everyone to try to solve this question. Let's see how we can solve this question. This is the original data frame, and the product column has different names. Some is capital character, some is lower cases. We can first convert this using the function str.lower to change everything to lower cases. And then the second question is replace this value with null. So we can just using the replace function to replace with np.nan. And also the third question is to drop duplicates based on the two column product and price. So we can just using the drop duplicates and based on these two columns. And after that, we can see this question is, I mean, the data frame is like this. Maybe if you check this, it's a little bit different because at the beginning, this all the apples has a price is 1.2. If it's like this, I mean, we don't need to compute the average anymore because it's already like the average price. But assuming the data frame it's different, maybe this apple is 2.2, then after that we will have two apples. Its price is different. If we want to compute the average, we can use this function called group y. Of course, we can just extract these rows and compute average by ourselves, but pandas has this function called group y. Basically, it's group everything in this column by its name and then compute the average based on the items after groups. So apple, of course, is be grouped together and to compute the average, if you're just using these two rows values to compute the average price. Yeah. That's yeah, that's how about I mean how we can pre-process the data. Before we end this slide, I'd like to talk more about the melt function. I just checked the documentation of the newest melt function online. So it actually take these several like input. The first one, of course, this is a data frame you want to apply on, and the second one is the columns used as identifier variable. This is like each column there should be a specific variable that's fixed, that's not changed. So we can use here I use date to represent it. So then, like you can see, each date is just like repeat several times in each rows, and the value var it means like which column of the value you want to convert it to long format. There is three columns here. So of course I can just using single column, but if I didn't input into this function, it will use all the columns and just change it to long format. And also because like these three columns are converted to a new combined column, you can say a name for it. For example, atom. Then after converted, this new column is called atom. And usually the value column is called value. But of course, if you want to change it to another way, name, you can use the value name to change that specific column names. And that's like the latest melt function. It just takes these few input to convert a data frame from wide format to long format. So that's all about today's like a lecture. Any question about the data pre-process? If no, I'd like to talk about our first exams. I think most students did pretty well on the exam. You might, if you notice, there's maybe a new notification from Moodle because the other TA, she's too strict on the results. So some questions and maybe you should be correct, but she marked it as wrong. So I have already changed it and updated your grade. You can check it out on Moodle. So let's see how these questions. So the first one is very simple. It's just a double, right? No, it's auto type. It is a float, right? And the second one, this one will return is 4. although there are two numbers, but they are in the same list, so it's just count as one. And the third one, split using blank space. So this first answer is using blank space. And the fourth one, of course, import numpy as np. And numpy average is 0. This one, usually many students made a mistake. They thought the first one is accurate, but actually the correct answer is the second one. Is there's a two parentheses here. And df shape will just return a tuple showing the number of the rows and columns. And to select the specific column, we can use these three ways, either .age or age name, or just using a LOC location function. So all of the above is correct. What function remove missing value? We use drop NA. And to create a numpy array is np.array. And a range is just from 2 to 10, and the intersection is 2. I mean the difference is 2. So each step is 2. So each time is just then 2, 4, 6, and 8, excluding 10. What will be the output of code? So this one is just like get all the rows and the second column, which then is then just 2 and 5, the first choice. And this one, read the CSV, we can use pd.read CSV. And iLocation, this one is just the third row, fourth column. So it's the first question is correct. And check missing values. So actually, all these three are okay to check missing values. Which statement is true? We know that for two-dimensional matrix, actually np.dot and np.matrix multiplication is actually the same. So the second one, they are the same. Oh, sorry, the third one, both they are the same result. df.describe, we just gave you a statistical summary of the columns. And D types, we just gave the data types of all the columns. What is replacing with 0? We just learned fill NA can replace the NA with 0. And also, what does this one return? So this is like a second row, third row, and second row, third row, and first column and third column. So this is a little bit confusing because it says row 1, 2, so it means actually it's actually just the second row and third row. So it's B. And to apply a function to each row of pandas, this is a little bit different from that map, because map just use dictionary. But if we want to apply a function, we need to use this df.apply. And for the blanks, so we need score greater than 8. So it's like score greater than 8. Yeah, that's the two blanks. And from 1 to 5, it's just from 1, 6, because this is excluding the other number, so it's 1, 6. And this one, to complete the function, we already know the function name is print height, so the function name here should be print height. And the thing inside this bracket, it should be hdict name, because hdict is a dictionary name, and name is a key to access the values, so it's hdict name. And this one has several answers. We can use -5. This is one correct way. And we can also count it from 9 to the end of the, that's also okay. And also some students use from 9 to 14, that's also okay. Yeah. So, and the final, the last one, because it's a CSV file, so we need to split it using a comma, right? And then the first column would then be just the first element in the list. Yeah. Any question about the question? No. Okay. Yeah. Then yeah, that's all about today's lecture. And if you have any questions, feel free to come and ask me. Yeah.